Welcome to Q&A Wire.
Hi, so in this case we're going to have the solubility product of lead bromide as a solid in order to generate lead 2 plus 2 equivalents of bromine minus, right? So we know that if we write down on our ice table, it doesn't matter the initial concentration, but a certain amount minus S, meaning the solubility, is going to change of the solid and get dissolved. So we're going to get plus S plus 2S, giving us equilibrium quantities S to S, and of the solid it doesn't matter because it's a pure substance and it doesn't enter our equilibrium constant. So the solubility product constant is equal to the product of these two concentrations minus squared, and as you can see this is going to be equal to 4 times solubility to the cube. So the molar solubility in the case of water is simply finding the value for S over here, since the solubility product is equal to 4.6 times 10 to the minus 6, S is going to be equal to 0.01048 molar, or 1.048 times 10 to the minus 2 molar. Next up, we're going to see what happens in a solution that is already containing one of the ions, and this is known as the common ion effect. So I'm going to alter a little bit this part. Actually, we're going to let this guy survive. And the only thing that is going to change is the initial concentration that we have of lead 2 plus or of bromine minus. So in the first case, we have a 0.27 molar solution of lead nitrate. So that means that my initial concentration of lead, it is going to be 0.27. Then gets us that at equilibrium we have 0.27 plus S and 2S. So now our solubility product constant, this is of case B, just to be clear, now becomes 0.27 plus S and 2S squared. So 4S squared. Now we're going to have a cubic equation that is KSP is equal to 0.27 times 4, so 1.08 S squared plus 4S cubed equals my solubility product, that is 4.6 times 10 to the minus 6. Here we have two different solutions. One would be that solubility 0, that it doesn't make sense. How can we say that? Because we can factorize 1s of both of these guys. Sorry, never mind about that statement. That is wrong. So we can go ahead and directly solve this equation. And the value for s that we find is going to be 0.002 056, which is equal to 0.056 times 10 to the minus 3 molar. And this would be our solubility in the first solution. So now let's go ahead and look at the result for part C. Again, we're going to leave all of the skeleton of the problem as is. And the only thing that is going to change will be the equilibrium and the initial concentrations. So now we have a solution that has a 0.027 solution of sodium bromide. So my initial value is 0.027 and 0. This now becomes S and 0.027 plus 2S. So now our equation now is S times 0.027 plus 2S squared. So again, we need to solve this equation for the value of S, and you're going to find the result is the value that we find for S, that is the real solution for this cubic equation, is 0.00383, which is the same as 3.83 times 10 to the minus 3 molar. And this would be all for all of the cases in hand. Thank you.